Hi everyone, in this video I'm going to be showing you some of the common methods of synthesizing amino acids. Okay, so amino acids have these general structures where the way I draw it, I first draw this 3-carbon chain, okay, and on right carbon I write the acid, which is CO2H. On the left, not on the left side, I'll just write the nitro group, okay? So that's the general structure. It's a carboxylic acid and amine group, okay? And in this carbon right here, there could be a various R group with a specific stereochemistry, okay? So this is R. So this, whatever the R group is, will determine the name of your amino acids, right? So there are 20 natural amino acids, and there are countless numbers of unnatural amino acids, okay? So how do we make them? So one of the methods of making it what we call is alpha substitution, okay? You might have seen it before, okay? So if you treat a carboxylic acid with PBr3, okay? If you treat carboxylic acid with PBr3, what you get is this acyl bromide, okay? Now, if you treat the acyl bromide with Br2, okay, this might look familiar, you do an alpha bromination, okay? So you add the Br group on the alpha, okay? And remember, this is one of the first things you learned this quarter, okay? So you do an alpha bromination, okay? It goes through an enol intermediate, okay? And with water, you hydrolyze this part of it. So it goes back to the carboxylic acid, okay? You go back to the carboxylic acid, but the Br that was added to the alpha position will still stay intact, okay? And the last step is what happens is you do an SN2, because you see ammonia is a really good nucleophile. So it attacks on this carbon and the Br leaves, and it furnishes you with this, which is alanine, okay? Right, do you see how that has structure as what I drew out, right? It is this on the right, this on the left, with an R group that happens to be a methyl in this case. So if it's a methyl, it's an alanine, okay? And the reason why they're charged, why this is negatively charged and there's positive charge, because amines are basic, carboxylic acids are acidic. In a physiological pH, that means it's the pH that your body's at. I believe it's around 7, okay? At that pH, the solution is acidic enough where the amine will gain a proton, okay? At the same time, it's basic enough where the carboxylic acid will lose the protons. So they exist as this charge separated, what we call zwitterion, okay? So that's one way of making it. So for this specific way of making it, your acid have to have carried the R group of the amino acid, right? So if my acid was this, right, if my carboxylic acid was that, I would have made a different amino acid. I believe that was isoleucine or leucine, one of them, right? And if your R group on the carboxylic acid was a benzene ring, that would have given you phenylalanine as the product, okay? So for the alpha bromination, your R group comes from your initial acid, all right? Next, another one we could do is reductive amination, okay? So for reductive amination, okay, remember, when you turn an aldehyde or a ketone with an amine, you replace the C double bond N with C double bond O with C double bond N, okay? So that's what you did here. You made an imine, and that imine could be further reduced to give you the amine, okay? So in this case, the way you do it is, so you have both a carboxylic acid and a ketone in the same molecule, right? So if you're with an ammonia, the ammonia will reduce onto the ketone, right, not the carboxylic acid, and create this, okay? And after, then if you treat that with NaBH4, you'll reduce the C double bond N to C single bond N to give you phenylalanine. Okay? So let's do a couple of examples. Okay? So it's asking you to make leucine via alpha substitution. Okay? So remember, for alpha substitution, we have a carboxylic acid, and wherever the R group is, comes from the carboxylic acid. So that means your starting material will be this. The only thing you append is an amine through an SN2, right? So your starting material has to be carboxylic acid with that chain on it. So if I were to draw it, CO2H, okay, that, okay, or that's the same as this thing, okay? And what do? We first treat it with PBr3 and Br2, okay? So remember, PBr3 converts the carboxylic acid into bromine, okay? And Br2 will add bromine on the alpha position, okay? And then what you could do is use ammonia, you do SN2, okay? And then if you hydrolyze that, it gives you your amino acid, okay? So this is NH2 or NH3 if it's typically written as charge separated, okay? And I'll be going over the rest of them in my sessions. Hope to see you all there.